Hello, Miss Bublets here. I wanted to go over lesson 1 from topic 4 just to make sure you have the correct answers and to point out what's really important about the introduction lesson for our last topic. It was called Early Study of Evolution, and words you need to know, of course, is species, variation, evolution, fossil, adaptation, and scientific theory. And on the very first page, what you should have done, which I know y'all have a tendency of ignoring the first page, but you're actually supposed to draw an arrow pointing to the squirrel that you think is better suited for the environment. So you should have pointed to the gray squirrel. The gray squirrel is going to blend in better on the wood and on the ground and be less likely to be hunted by predators because it's not quite as noticeable as that white one. That would definitely get picked off by a hawk or by an owl quite easily. So I wrote the gray squirrel is better suited to the environment because it is darker. The gray squirrel will blend in better and is not as obvious to the predators. So you should have drawn an arrow pointing straight across to this guy right there. Over here we're talking about the curiosity about how life changes. Scientists such as Charles Darwin were also curious about the differences they observed in the natural populations. A variation is a difference between the individuals of the same species. So gray fur versus white fur. Some scientists ask how life on Earth got started and how it has changed over time throughout the planet's history. So, very important. Also at the end it says that Darwin and others worked to develop a theory of evolution. This is a very important definition right here. I don't know why I didn't highlight it. Evolution is the process by which modern organisms have descended from ancient organisms. Maybe at one point there was this 10-foot tall squirrel. Who knows? Also, you'll see the interactivity up here. You notice I had already assigned that. A lot of you have already been doing that, but it was the one called Adaptation of Animals. There is a worksheet that goes with that, and then you upload the worksheet into Edsby Gradebook. Let's turn the page. I apologize for all the sounds of roosters and dogs barking. I really don't have any control over that. Here, pay attention, you're supposed to make up a key. So my key was, if it's a pointy pebble, do a triangle. If it is just a round petal, I put a circle. And if it's a seed pod, long and narrow. So go through all these pictures. So I put triangles on anything that was pointy. Just to a few. Then put a circle around those that are round. Some more round over there. And then seed pods. These are the seed pods right here. If you get outside, you may notice a beautiful tree that's in bloom right now that's yellow. And it's covered in seed pods. And while I was eating Easter dinner yesterday, a seed pod flew right into my tea. So they make these pods, and they're very, very light, and they get picked up by the wind, and that's an adaptation. So that plant, that tree in particular, can get its pods spread around. As you go down, you'll notice that the Linnaeus system for classification. Remember, I scheduled a brain pop on classification. Again, this is something we learned in the beginning of the school year and that you need to come back and redo. It's all about species and genus and species. You notice the videos I've been posting on YouTube, I always put the genus and species. Remember, genus and species are the scientific name of an organism. Genus is capitalized and species is usually lowercase. And as we did in this video and quiz and worksheet on classification, you had to figure out which one was the most related, that had the most things in common. And of course, nothing is more related and have more things in common than species. Domain, of course, was the least related. So that's why domain was always less than anything else. Lamarck. You're going to see quite a few questions comparing Lamarck to Darwin. Unfortunately for Lamarck, he attempted to figure out how organisms came to be, just like Darwin did. But as for him, he did not come up with some correct hypothesis. They could not be proven. They could not have experiments to back them up, and therefore they failed. But first it says he thought that organisms could change during their lifetime. That's like when I shot that video of the woodpecker the other day. I told you that woodpecker cannot make his beak longer because he's trying to reach further to get an insect out of that old dead tree. Animals cannot make any changes to their own body during their own lifetime. So that was the biggest mistake he made right there. He actually hypothesized that if two bodybuilders married, that they would have a baby born with big muscles. It's just not true. So his theory of transformation, as it's known, it did not hold, and it did not have anything to back it up. But let's talk about some things that were correct. First, he suggested that evolution takes place in small, gradual steps. That is true. He also proposed that a simple organism could develop over many generations into more complex organisms. Darwin agreed with these two, and we're going to see this be our answer on page, I think, 202 when we have to answer this question. But this is where the information comes from right here. So, hypothesis. Why is it helpful for hypothesis in subjects like history and science? It gives a starting point for further investigations. Coming on down, you were supposed to draw a little creature who was not using his claws anymore, and therefore the claws started getting shorter and shorter. And this is this whole theory of transformation. Can you imagine if you didn't use your left hand very much and it all of a sudden just started getting shorter and shorter because you're right-handed? Of course that's not going to happen. Theory of transformation, when you read this page, is not true. Lamarck was incorrect. So make sure you don't just go through this and read something and think you're reading the truth. You're reading something that was disproved. So make sure you know that. It could not be proved through experiments. And you're drawing this guy with shorter claws and you're making that observation right here. So by all means, don't go through these 2 pages and think what you're reading is true. It's not true. More background information. You learned hopefully in 6th grade about the law of superposition. And the law of superposition states that the oldest rocks or fossils are always going to be found at the bottom. I use these as like different layers of the earth, whereas the youngest is always found on the top. And this is the process of deposition. As things get laid down, whatever got laid down first is oldest, and then this goes on top, and then on top, and on top, and on top. Imagine an analogy that you did all your laundry yesterday, right? Everything's clean. Now today you take off your clothes. Where does it go? To the bottom of your hamper, providing you picked up your clothes. Then tomorrow you take off your dirty clothes. Where do they end up? On top of the clothes you put down for Monday. And so on and so on. By the time you get to Saturday night, your hamper's probably getting pretty full. And the clothes that you wore most recently, the youngest if you will, they're going to be at the top of your hamper. And the clothes that you wore last Monday are at the bottom of your hamper. So, law of superposition. Hopefully you remember that. Mary here, scientists began to realize that some animals had lived in ancient past but no longer existed. You know what? 99% of all the species that have lived on Earth of 4.56 billion years have become extinct. We're the 1%. We're the survivors. We're the ones who are able to adapt, and all the animals that are here with us. So Charles here, he was the first one to suggest that the Earth is not 6,000 years old, that he thought it was more like 300 million years. And then as time goes on, we've learned that the Earth is 4.56 billion years old. So again, these were two people early on who did a lot of contribution to this type of science. All about Darwin's journey. I have assigned this week a brain pop, Charles Darwin, so try to do that pretty soon. And again, we did a poll question on the Beagle. The Beagle is a ship. Need to know that. Scientists have collected that there are over 1 million different species on Earth. There's about 10 million different species on Earth. And every year about 10,000 more get discovered. So much of Earth we have not even been there yet. Here you notice that both have hard shells, both have short legs, and their defense mechanism is that they can curl up and protect the softer parts of their body from predators. And of course they're talking about today's armadillo and probably a common ancestor of this armadillo. Again, this is all about the journey he took in the south part of the world. And again, I told you in one of my other videos, it's all going to be about the beaks. They're comparing the beaks, the function of the beaks, what they're able to do. And they noticed that the birds in South America and the birds of the island off of South America, they did notice they did have some similar beaks and they did have similar color patterns. And these help them to survive in their different environments. Make sure you got this matching correct right here. Pause the video if you need to. And going on down, it says, what do you think explains the variation of bird beaks? On the island, there is competition for food. Variation in beaks would lead to different food. And remember what I told you about the woodpecker video. We were talking about beaks in there. And it says, Darwin, that species can change over time. He noticed that differences had developed with the island and the mainland species. If the food source was different, the bird, in order to survive, the beak had to adapt or die. Here's your vocab word, adaptation. Super important. An inherited behavior or physical characteristic that helps an organism survive and reproduce. Next chapter, we're going to learn the word fitness applies with that. We're also going to do a gizmo. Our next gizmo will be the one on natural selection. His hypothesis, developing a theory. This is probably the most important part of this whole lesson. I put a big star. This is the theory of evolution right here. And all of this has been highlighted in pink. Species change over many generations and become better adapt to new conditions. Darwin hypothesis was an idea that contributed to important new knowledge. Later, he and other scientists used it to test and develop a scientific theory. So what's the difference between a theory and a law? A theory is a well-tested explanation for a wide range of observations and experiments. Based on the body of facts, scientific theory is confirmed repetitively through observation and experimentation. Darwin's ideas are used or often referred to as the theory of evolution. And you know what? When Darwin talks about time, we're not talking about last week. We're not talking about last year. We're talking thousands of years ago. So when you hear about time in this topic that we're on right now, it's a big amount of time, no short amount of time. They explain why things happen. Theories explain why things happen. They are well tested and confirmed through much repetition. Why? It's the why. You need to remember that. Make sure you added made observations right here and you wrote tested hypotheses right in there. Make sure that was done. Okay, and finally, this is what these answers should look like. Some of you have already done sea palms, fossils, evidence of evolution. It goes along very well with this unit. But go on ahead and check your answers. Fossils are direct evidence of evolution. They show changes over time. All animals inherit adaptations, traits, or characteristics that help it survive and reproduce. Variation is a different trait. And number 3, evolution takes place by small gradual change. I read that to you earlier, and here's my number 2. I ran out of space. Simple develop into more complex. And then answer number 4 is right here. And this is talking about a blackcap. It's a type of bird that has a migration pattern. And they found that as the birds went through certain areas, the birds that had adaptations to find food better, had the different physical traits, they did better, and eventually could lead to different species. Different migration patterns, physical traits along the way were changing, and you end up getting a different species. Okay, remember you can pause this anywhere you need to so you can check your answers. Thanks a lot. Bye-bye.